morning. My name is Marita Kotze. Welcome to this session. I'm just going to wait another minute for all the attendees to log into the system. So yes, and while you're waiting, you can download the presentation in the box to the right or below on your screen, the PDF. Make sure that you go through it. I'm set the PowerPoint presentations like notes so that you can afterwards use it as notes as well. So yes. Okay, I'm just going to wait. Okay, welcome to this session this morning. My name is Marita Kotze, Senior Education Specialist for Physical Sciences. And before we go on with this online class, let's cover some of the basics. Right, if you're struggling to hear me, make sure your audio is on and your speaker volume is turned up. You will be automatically muted. And I'm not going to answer any questions during this session. You can ask all your questions in the question box to the right or below on your screen in the question box. So make sure that if you do have any questions for me, to write it in the question box, or you can send me an email to academics@impact.co.za, or you can send me an email to impact@impact.co.za. Either way, it will get to my attention. All right, you can visit Impact's website for the recording of this session at the link, as you can see it here, and you can go to COVID-19 online schooling class videos. So again, if you do need any or have any questions, send me an email, and very welcome to the session this morning. All right, let us start. The information that I'm going through today in this session is grade 10 and 11 work that you need to understand your grade 12 physics. All right, some of it will be new to you, some of it will be just, okay, I know that. All right, so I just want you to bear with me, because this is really, it's the basic physics stuff that such a lot of learners do have problems with, and that's why I feel that I just have to make sure again that all the building blocks for physics are, you do have it and you are prepared to apply this knowledge for your grade 12, grade 11 and 12 work that you're writing about. Okay, physics especially. Okay, we are going to do mechanics and scalars and vectors, movement in one dimension, vectors in two dimensions. All right. So a quick reminder about the difference between weight and mass. Mass is your amount of matter, and weight is the attraction of an amount of matter to the Earth. So what are we doing? We just take the mass and we multiply it by 9,8. In this case, it was multiplied by 10 meters per second square, and therefore the 1,500 newtons. Right, and it's downwards because the direction, there must be a direction. So what is scalars and what is vectors? I'm just going to go quickly through this, because as I say, this is old news for you, but maybe this can help you a lot in your paper, physics paper. All right, so scalars and vectors, it's all the quantities, all the physical quantities that you get in physics are divided into two groups. The one is scalars, the other is vectors. All right, scalars, distance, speed, time, work, temperature. In this case, the car weighs 2,000 kilograms. The mass is 2,000 kilograms. His weight is 20,000 Newton. So therefore, and it's 20,000 Newton downwards. You have to, listen learners, you have to draw a vector with an arrow. If there's no arrow, you cannot get marks for that. So please, important, it must be presented with an arrow and the arrowhead indicating the direction of the vector, and as well as an angle that the vector does have. All right. So now, what do we have here? I do include a table of the different scalars and vectors. Some of it, it's just examples, but what's very important, as you can see here, are the units, and these are SI units. Learners, you need to know the SI units. If you're not using units, you will not get any marks. It's so frustrating when marking grade 12 learners papers and there's no units. Then I thought by myself, you do all the calculations, go through all of it, make sure that you do it correctly. But the answer is without a unit and when there's a vector without direction. So I cannot understand this, but please, if you're not sure, download the science clinic. If you didn't do it yet, please download the science clinic notes for you. I will, in any case, at the end, state that information again. Download it and make sure that you do know the different SI units. Right. Okay. So distance, the vector will be the moment when there's a direction with it, it will be a displacement. Speed, moment, direction, velocity, mass and weight. All right, acceleration, force, momentum, impulse, all of them are examples of scalars and vectors that you do know. All right, so what is a scalar? It's a physical quantity with only with magnitude, no direction. Your vector will be with unit and direction. The resultant, what is the resultant? This is also scary. Some grade 12 learners don't know what's a resultant. So make sure that you do know the single vector that will have the same effect as the original vector taken. That's the resultant. Okay. The direction of a vector. Well, there are three ways you can represent the direction. The first one is a compass, and that is where we have north, east, south, and west. All right. So if we have a vector, and it's for example velocity in a certain direction, so then you will say, so for example, 2 meters per second, 30 degrees northeast. All right, that is a compass way. Another one is velocity 30 degrees east of south. All right, so we might have to make sure that if you read the scenario, and then you can see if they give the scenario in an east and western direction, then you have to use the compass, right? So it depends on in which scenario you will find question. Right. So the next one is bearings that we use in the navigation of planes and ships. North is 0 degrees, east is 90 degrees, south is 180 degrees, west is 270 degrees. So make sure that this is the most commonly one used. You will see that from the north, that's 0 degrees, just around it, it depends on which direction it is. So now you will say it will no longer be 30 degrees north to east, it will be a bearing of 60 degrees, right? So, and that will be of 210 degrees measured from the 0-degree line. All right, so the direction of a vector relative to another vector. All right, relative to another vector, you will see you have A and B, and A and B and B, different places relative to it. In each of the above cases, vector A is at 30 degrees to vector B. Okay, so you will state then that the direction of A is 30 degrees of 30 degrees to vector B. All right, or 30 degrees downwards, 30 degrees. If this is a 180 degrees, you will say it's 30 degrees west of south, or whatever. So make sure that you do know how to apply the direction. So the direction of a vector is always measured at the tail of the vector. All right, so here you can see the vector again with the arrowhead and the region is tail. Graphical representation of a vector. That's the way it is. So please remember the arrow. Any vector can be represented by an arrow. So here we have 10 meters to east, can thus be represented. If we look at it, we will see there it is. We use a scale, 1 centimeter equals 1 meter. In grade 12, not necessarily anymore. It's not necessary to draw one, or there's no time in a question paper for that. But that is what you did until now. You don't know at this stage what will be asked in a question paper, but yes, for now, it's just to show you the 10 meter east here is represented by a scale, and you have to write the magnitude, the unit, and the direction. All right, forces you are familiar with, all the force diagrams. This is an easy force diagram. As you can see here, you have the 10 Newton, 20 Newton to the left, and you can just add them together to have one resultant. There is a 6 Newton to the left, 12 Newton to the right, then it will be 6 Newton to the right. Okay, so that we call it the net or resultant vector. So this will be F net. So the single vector that will have the same effect as the original vector together, that is your resultant. So we learn and we know in grade 12, you will say F net. All right, so that is the resultant vector in both of these for us. Make sure, this is the addition of vectors. Just add them together as we can see here. So your resultant is 25 meter east, that is 15 meter west, 5 meter east, and your resultant will be 10 meters west. So vectors in the same direction, for example, a man walks 10 meter east, and then for the 15 meter east, you can just add it up. So the resultant displacement will be 25 meters east in opposite directions. The resultant displacement, you add them together as well. As long as you know this is linear in a straight line vector, you can add it together, but you need to state which way is positive. All right, so movement in one dimension as you did it in grade 10 and grade 11, and we're using it in grade 12 as well. Displacement, velocity, time, and acceleration. So movement in one dimension, we will look at these 5 topics: position, movement, one dimension, distance, displacement, speed, velocity, and acceleration. So what is position? It's the position of an object is measured from a specific point in a positive or in negative direction. So as we look here, we have an example here of Amy's house, City Hall, Alex's house, and a boy moving from Alex's house and to, say, for example, 9 kilometers from Alex's house. So if this guy is driving to the left, he will be driving to the west in a negative direction, and east will be in the positive direction. So make sure that you need the direction. So what is position? Position is therefore the place where an object is relative to a reference point. So what is the reference point here? The reference point here is the man. In the Doppler effect is the application that we do have here, right? In the Doppler effect, you here. So there you can be either standing on a platform and the train is coming from the left and moving to the right. So here we apply certain knowledge. So your reference point is the guy that's standing on the platform, that's you, and that is the reference point, is the place of origin. All right. So what is the boy then? The boy is in the train that's moving from the left to the right. The left will be the negative direction. The right will be the positive direction. So in the Doppler effect, if it will coming from the left side to the right side. So it's coming from the negative left to positive to the right side. So it depends on what we have as reference point here. And remember, your reference point does not move. All right. So although the boy is standing in the train and he is not moving, the train is moving, and you that's standing still on the platform you will see it as if the boy is also moving in the train. So make sure that you do understand the reference point. So movement along a straight line, as you can see here from A to B, you can just add it up together. The car has moved from point A to B in a specific time. All right. So now, what are we going to look at? Distance and displacement. So yes, you need to understand the difference between distance and displacement. If we ask distance, it's not, you're not going to give any direction. If you give any direction, you will don't have any marks. So make sure that you do know the difference between distance and displacement, the terminology. The one is the scalar, the other one is the vector. We're not going to ask you the difference between displacement and distance. You need to know and apply the knowledge that if in the question the distance is asked, you just answer the question with the unit meter. If the displacement is asked, you answer it with a unit plus direction. So that is why I'm going through this at this stage with you, so that you can see that this is why it is important to look at your grade 10 and your grade 11 work in order to get your full marks in grade 12. All right. So therefore, what do we have next? All right, we have a line A, B. All right. So what will be the distance from A to B, the white line and the yellow line? All right, the straight line AB, that will be your displacement, and your answer will be 20 meters to the east. What is the dotted line? The dotted line AB will be the distance, and you will say 30 meters, and no direction. All right. So distance and displacement. All right. So what is the difference then between a vector and a scalar when we're writing formulas? All right. A vector is written with an arrow to differentiate from a scalar above your symbol. All right. Speed is the rate of change of the distance. So if we ask Lennis again, speed is asked, distance divided by time. V equals d over delta t. This formula is not on your formula sheet. You have to know that. So please take your formula sheets that you do have from your test in March and write all the formulas on the formula sheet that you don't have on the formula sheet that you are going to use. All right, so the unit is meters per second. So remember, if it's given in kilometers per hour, you need to change it to meters per second. So velocity is therefore the rate of change of displacement. So yes, we have the same formula, but it is displacement over time. So therefore we cannot use the same formula. That formula is also not on the formula sheet. There are movement equations and formulas, but please make sure that you do know this one. V is delta x over delta t if it is a horizontal movement, and if it's a vertical movement, we will use delta y over delta t. And the unit is meters per second, and remember direction. Now you can ask me now, but ma'am, where will I use this? All right. As I said just now, movement equation, this formula is not there. Right, so say for example, V final equals V initial plus delta xt. So that formula, if you don't have the initial speed and you need for the motion equations formulas, you need 3 of the variables in order to calculate the fourth one. So if there are only 2 and you can calculate the velocity first with this formula, use this formula to calculate the velocity first. Either initial or you're going to use either the initial velocity or the final velocity. So when adding velocity vectors, you always assign a positive direction. Please, learners, you must state which direction you are going to take in the calculation as the positive direction. So here I do have an example. A swimmer can swim at 2 meters per second and swims downstairs in a river flowing at 3 meters per second. It's downstream in a river flowing at 3 meters per second, due east. Find his resultant velocity. This is an easy question. So you have a swimmer that swims at 2 meters per second east, a river that flows 3 meters per second. So what will be your resultant? Add them together, 5 meters per second east. But what will happen? What will the resultant velocity be if he swims upstream? Again, the stream 3 meters per second east. The boy swim 2 meters per second to the west, so that is why it must be in the negative direction. But it's not, you're not going to use the minus and the west at the same time. If you, because that the minus will be for the west. That's the same. It's a double indication of the direction. So please make sure that you do understand what direction you're going to use here. The resultant will therefore be 1 meter per second east, and there the direction to the right is positive, so the direction to the left will be negative. So you can either use east state, east is positive, or you just draw an arrow with a plus on top of it, so that the marker will know which direction you use as positive and which direction will then be negative. Why must you state that? Because when marking a paper, the marker is not necessarily sure of which direction you take. So by indicating the direction, it's easier to mark the paper. And if you take another direction that's not on the memorandum, then the marker must give you the marks in any case because you take the opposite direction. All right, so acceleration. When we look at acceleration, we will see final velocity, initial velocity, and change of time. All right, so what does it say about acceleration? It's the rate of change of velocity of an object. Now, what is the rate of change? Change is delta of velocity. So delta V is V final minus V initial. Right. So remember, when using the gradient, when you have to apply your knowledge for your question papers, say for example a graph, if you have to calculate the gradient, make sure that you use A2 minus A final minus A initial, right? So divided by X final minus X initial, if you grade it. All right, so now your unit for acceleration is meters per second square plus the direction. Why is it meters per second square? Because it's meters per second divided by per second. So that's why it will be meters per second square divided by second. We only deal with problems with constant velocity and constant, no, not constant velocity. We either deal with problems with constant uniform acceleration. Uniform is another name for constant. All right, so the direction of acceleration, there's a confusion between these two with learners. So if the speed is increasing, then you will have both the acceleration and the velocity in the same direction. So, and either way, if it's to the right or if it's to the left, you will see they are both in the same direction. Now, what will happen if the acceleration and the velocity is in opposite directions? So the object's velocity will decrease. Okay, the object's velocity will decrease. As you can see here, it is decelerating to the stop sign. Okay, so when that is happening, the velocity decreases. Why? Because the acceleration is therefore in the opposite direction. Right. So vectors in two dimensions, that are the vectors that most of the vectors that you're using will be in different directions. Okay, types of problems. You have to determine the resultant by adding vectors into components graphically and into components by calculation. So here we do have two vectors. As you can see, the two vectors are not in the same direction. So you cannot just add them together. So your resultant will be from the tail of the one to the head of the other one. So this is the triangle method. Use it only with two vectors. Where are you going to use it? Say, for example, forces, work energy power. Any of these mechanics questions, you can use any of these methods. Okay. The resultant, therefore, is the effective value of the two vectors taken together. Also called the tail to head method. And the magnitude and direction of the resultant is obtained by drawing from the head straight line from the tail to the head. All right, so this is for vectors that are not linear. All right. So next thing is if we do have two resultants that start at the same point. And that is the parallelogram method. Two vectors are drawn from the same point. So what do? Parallel is completed by drawing dotted cross construction lines, as you can see here. Dotted construction lines. So the resultant is then the diagonal between the two. From the same point, the tail of the two. Right, as you can see, the tail of the two, these must be parallel to these. Make sure that you do know that. All right, so now what is this? This is a lot of vectors following each other. All right, so you can see here velocity 1, 2, 3, 4, 5. So you draw a polygon. Okay, and then you will have the resultant by again do the same thing using the head to tail method. All right. We use this own method only if there's more than two. Okay, here is the summary of all of the vectors. Resolving vectors into components graphically. As you can see here, this is not something that you will do anymore in grade 12. You don't have time in your papers. So please don't try to do something graphically, except if they ask you, but it's not likely that they will ask you to do a graphical resolving of vectors. But if you want to do it, and you can do it very quickly fast, just to cover yourself to see that you did to decide the correct calculations, please make sure that you can do it. Right, so resolving vectors into components by calculation, where you do have force in a certain angle. By having a force at a certain angle, remember all the force diagrams, you will have a y component and a x component. All right, so your y component will be sin and your x component will be cos theta. All right, so by broken up this single vector into two different vectors, you have to make sure that you do understand which one is the fy direction and which one is the fx. Y is fx cos because it's adjacent over hypotenuse. Right. So that's why it's cos and adjacent. So make sure that you do understand the difference between the cos and the sine, why the one is cos and the other one is sine. Right, if we look at vectors on a slope into components, this will definitely be in a question paper. Each one, you have to make sure that you do understand the difference between the two and how to do the calculations. Okay, it's an object on a slope and the angle between the slope and the parallel surface here, or the surface here, that angle will be the same as that angle. Right. So this is the weight of the object and perpendicular with the object, you will find the perpendicular component. And again, it's cos theta, and the parallel component is sin theta. All right, sin theta. Okay, if we look at the car with a mass of 1,500 kilograms is parked on a slope of 30 degrees. Always draw your diagram, a labeled force diagram or a labeled free body diagram. Now this is a force diagram and it's labeled, but when drawing it, you must make sure that you draw either these two or only that one. With these two, you can draw in dotted lines. But make sure that you're not drawing all of them together, because if you draw all of them together, it's -1. So make sure that you draw this in dotted lines if you want to draw. Okay, so calculate the component of the weight of the car that is parallel to the slope or perpendicular to the slope. They can also ask you calculate the force that's pulling the car down the slope. Right. Then you need to know that is the parallel slope. That is an application of what we do have here. All right. When the car moves further up the road, the slope increases to 40 degrees. Now you have to explain a level 3 and level 4 type of questions. How will the components of the weight change respectively? So now you want to know the parallel and the perpendicular component. How will it changes? If the slope increases, the perpendicular component will decrease. Okay. And so therefore you need to know what is happening with the magnitude of the parallel component and the perpendicular component. Right. Angular velocities. For example, you have a swimmer that heads directly across the river, as we did previously. His resultant direction or velocity. Now, in this case, the swimmer heads directly across the river and find his resultant velocity. You swim 2 meters per second, and the flow of the river is 3 meters per second. So where will the swimmer end? It's from the tail to the head. So your resultant will be there. Okay. And your angle is especially 3.6 centimeters at 56 degrees to the bank of the river. Okay. So swimmer gets carried downstream and does not go directly across the river. So in this instance, what is happening here? The swimmer tried to swim across, but he ends up there. Right. So now, what will happen if I want to go directly across and I'm able to swim 4 meters per second? What must he do? He must swim upstream. So what will he do? He will swim in order to get from here to there. He must swim 4 meters per second at a certain angle to the bank in order to get this. The resultant will therefore be a degree directly across the river. Okay. So why is it from the bank here to there? It is because it's across the river. You can either ask the resultant or can ask in which direction and at what velocity must the swimmer swim in order to get across the river. So that's why you will do the calculation by using your sinus and cosinus rules for the angle and by using Pythagoras for them to get the resultant here. Okay, it's all right. I always include this part in my slides for the learners that's not part of Impact. So we do have the Doxatia textbooks, summaries, mind maps, and question papers. You can order an exercise book or exam papers from them. They are also downloadable for free exam type of papers so that you can download from the website. If you don't have other resources, this is a very good resource to use. So yeah, okay. Then the Quanta series are books that you received this year in your package. impact learners. If you're not an impact learner, you can order the book. It's a summary book with exam question papers. Now, it's a lot of exam type of questions in it. I do have a learner last year that sent me an email. He got 53% in the prelim exam, and he really wants to go and study the BSc degree. So he needs to have more than 60% for his physical sciences in order to get into the university. So yes, what did he start to do? I sent him a Quanta book, and he worked through all the questions in the Quanta book, as well as previous Sakai papers and DBE papers, and he increases his mark to a mark into the 70s. So learners, please, just by working through question papers and question papers and question papers, make sure that you do understand the answers. If you work through the questions in the Quanta books and you do have an answer and not sure why that answer is what it is, you can just simply modify it. Okay, the other thing is that the memorandums of the multiple choice questions are very good. So there's an explanation for the memorandum. Why is it B and not C or etc. Important are the DVDs at the back of the Quanta book with explanations by Mimi Pretorius who explain the most important keys of physics and chemistry on the DVDs. Make sure that you do understand and that you look at the DVDs if there is something that you don't understand or need some explanation on. Okay, then science clinics notes and exam seminars. If you don't download it yet, go and download the prep books, the smart prep books, and you can, that's for free, and you can register for the webinars for the rest of the year. Exam seminars, that's very, very good. They're working through past papers, explaining the past papers. So yes, and the questions in the past papers. So make sure that you register for that and that you state that you are an impact learner, because if you are an impact learner, some of the times they could a discount. You are an impact learner, and you will see in any case that you have to state that you are an impact learner. If you click on the website, click on the center or the school, you will see if you start typing in impact, there are various impact centers. In any case, on that, just click on one in your region and make sure that you register them. All right. So if you do have any questions, you can send through your questions. I'm not going to answer any questions on this platform today. Send it through, write it in the question box to the right or below. And you can as well send me an email to info@impact.co.za or academics@impact.co.za. Thank you very much for attending today's class. If you have any questions, please send through your questions to me. For attention, Ludwig Kotzer. Thank you very much.